On August 25, 1981, the space probe Voyager 2 reached the Saturn system.
It was sent out to study the outer planets of our solar system. This historic flyby marked a major milestone in space exploration. Humanity gained its first close-up look at this magnificent ringed world. The probe's cameras captured thousands of high-resolution images. These images revealed the complex structure of the ring system. Scientists on Earth eagerly awaited the transmission of new data. The journey had taken years of precise mathematical calculations. Every instrument on the probe was calibrated for this encounter. The mission was already exceeding all scientific expectations. As it passed by, the probe also photographed several moons. Titan appeared unusually dark due to its dense, hazy atmosphere. This thick layer of nitrogen-rich gas reflects very little light. It also captured images of Tethys and Dione. In these early photos, they appeared as faint white dots. These moons were thought to be geologically dead ice worlds. Their surfaces bore the scars of billions of years of bombardment. But the most surprising discovery was yet to come. The probe was heading toward a tiny, mysterious moon. This small world was known to astronomers as Enceladus. When the spacecraft approached Enceladus, the photos puzzled scientists. The images sent back to Earth were unlike anything expected.
A team of specialists gathered to study the incoming images.
They immediately noticed that the moon did not look normal. The data transmitted to Earth suggested a very young surface. They immediately noticed that the moon did not look normal. This was highly unusual for a body in the outer solar system. Most moons are billions of years old and covered in craters. But Enceladus seemed to have been recently resurfaced. This geological asymmetry puzzled the imaging team. The boundary between the old and young terrain was sharp. Voyager 2 could only provide a brief glimpse of this mystery. If we look at the image taken from 74,000 miles away, the northern hemisphere looks like a typical cosmic graveyard. It is densely populated with ancient impact craters. But as your gaze moves south toward the equator, the scars from ancient meteor impacts suddenly disappear. Instead, you see smooth plains marked by tectonic fractures. These fractures indicate active geological forces at play. The southern hemisphere shows no signs of ancient bombardment. It is as if some process is continuously erasing the craters. Fresh material must be resurfacing the moon over time. This smooth surface is one of the most reflective in the solar system. It reflects almost 99% of the light it receives. These fractures, or cracks, are geologically very young. This anomaly suggested that Enceladus was geologically active. Scientists began to formulate theories to explain this activity. NASA specialists proposed an extraordinary hypothesis. What if there is a huge ocean beneath the icy surface? This ocean could be kept liquid by internal heat sources. Geological activity could be constantly reshaping the landscape. But this idea seemed incredibly bold at the time. This tiny world has almost no atmosphere to speak of. It lies almost 10 times farther from the Sun than Earth. At this distance, solar heating is extremely weak. According to the laws of physics, any water should be frozen solid. It should have remained frozen for billions of years. Enceladus has a diameter of just 310 miles. It is so tiny that it could fit within Arizona. This makes it one of the smallest major moons in the system. If there was a road built along its equator, driving at 60 miles per hour would take only 16 hours.
Doing the same around Earth would take more than 17 days.
This highlights just how small Enceladus really is.
Compared to our moon, Enceladus is 7 times smaller. And it is hundreds of times lighter in mass. Yet, despite its small size, it is remarkably spherical. Astrophysics dictates that small objects are rarely round. They simply lack the gravity to pull themselves into a sphere. Most small moons look like irregular, rocky fragments.
Pan, for example, looks like a giant dumpling.
But Enceladus is almost perfectly spherical.
Its silhouette is remarkably smooth and even.
This suggested that the interior was once warm and plastic. A liquid layer would allow the moon to achieve hydrostatic equilibrium. This was the first clue that something lay hidden inside. This mystery would remain unsolved for over 2 decades.
In 1997, NASA and ESA launched the Cassini mission.
Its destination was Saturn, to study the planet and its moons. The journey would take 7 years of deep space travel. It carried advanced instruments far superior to Voyager's. Scientists were eager to get a closer look at Enceladus. The spacecraft was scheduled for multiple close flybys. The new images revealed the surface in unprecedented detail. These fractures were nicknamed tiger stripes by the team. Heat was escaping from the moon's interior through these cracks. This heat was the driving force behind the moon's activity. In 2005, Cassini made a stunning discovery. It detected giant plumes of water vapor erupting into space. The probe actually flew through these plumes to sample them. Its instruments analyzed the composition of the erupted material. They found water vapor, ice crystals, and simple organics. This was direct evidence of a subsurface liquid ocean. The ocean was global, beneath the entire icy crust. Hydrothermal activity was occurring at the ocean floor. Enceladus became a prime target in the search for life. The plumes were continuously replenishing Saturn's E-ring. It revolutionized our understanding of the Saturnian system.
In 2017, the mission came to a dramatic end. In 2017, the mission came to a dramatic end.
But the data it collected will be studied for decades.
The search for answers did not stop with Cassini.
In 2023, the James Webb Space Telescope took a turn. It aimed its highly sensitive infrared cameras at Enceladus. The resulting image shocked astrophysicists worldwide. It revealed a plume of water vapor extending 6,000 miles. This was 20 times larger than the moon itself. But further analysis confirmed the water vapor signature. The water is being ejected at an incredible rate. Most of the water escapes the moon's weak gravity. It forms a giant donut-shaped cloud around Saturn. This process has been ongoing for millions of years. The source of this water is the subsurface ocean. Tidal forces keep the ocean warm and liquid. This tidal heating prevents the ocean from freezing solid. It is a dynamic, active world in a frozen region. Scientists are now planning the next phase of exploration. Future missions will search for direct signs of life. They will use advanced biosignature analyzers.
These instruments can detect complex organic molecules.
They will look for the building blocks of life. The surface of Enceladus is covered in fresh snow. This snow is actually frozen water from the geysers. It falls back to the surface, coating the southern pole. Over millions of years, this has created a thick layer. This layer of fresh ice reflects almost all sunlight. It is much brighter than our own moon. It is much brighter than our own moon. Water vapor condenses into ice as it escapes. This creates the spectacular plumes observed by Cassini. These plumes are a constant feature of the moon. The ocean beneath is estimated to be miles deep. It is kept warm by hydrothermal activity at the bottom. These vents release minerals and chemical energy. This environment is highly favorable for microbial life. It is one of the most promising places to look. The plumes provide a free sample of the ocean. We don't even need to drill through the ice. We can sample the ocean directly from space. This makes exploration much easier and cheaper. The James Webb data has confirmed this potential. The massive plume extends thousands of miles. It interacts with Saturn's magnetic field. This creates beautiful auroras on the giant planet. Enceladus is a tiny moon with a huge impact. It is one of the most exciting worlds in our system. On October 28, 2015, Cassini made its deepest dive. It passed just 30 miles above the South Pole. Its instruments were bombarded by ice particles. They detected free hydrogen in the plumes. This was a key indicator of hydrothermal activity. It confirmed that the ocean floor is geologically active. These reactions produce hydrogen, a key food source.
Microbes could use this hydrogen to produce methane.
These reactions produce hydrogen, a key food source. Enceladus has all the ingredients for life. It has liquid water, energy, and organic compounds. This makes it the most habitable place in our system. The search for life is now focused on this tiny moon. Future missions will search for direct signs of life. We may soon find the first evidence of alien life. Enceladus is a tiny moon with a huge potential. The next generation of explorers is ready to go. They will unlock the secrets of this frozen world. And answer the ultimate question: are we alone?